Remember this morning, you woke up, squeezed out a little toothpaste, spread on a thin layer of cream. But do you know what? The tube of toothpaste you used this morning, the pure white paint on your wall, and those spacecraft in orbit have in common? The answer is titanium. You have always thought titanium was something distant, something that only appears in spaceships, fighter jets, or operating rooms. But in truth, titanium has been around you since early morning, just not as a shiny block of metal. The compound titanium dioxide has long been used as a widely common white pigment. So, if titanium is so abundant and so close to everyday life, why aren't cars, bridges, or the pan in your kitchen made from it? Welcome to Everyday Things Explained. The metal too good to be cheap. To engineers, titanium feels like a material from science fiction. It is as strong as steel, but up to 45% lighter. It can withstand extremely high heat, and it is immune to corrosion from seawater. Most importantly, titanium is biocompatible. Unlike iron or copper, the human body does not reject titanium. And that remarkable biological property has made it an ideal material for artificial bones and medical devices. However, titanium is like an expert who is exceptionally good, but charges far too much. In aviation, reducing an aircraft's weight by 1 kilogram can save thousands of dollars in fuel. In medicine, a titanium pin can be the boundary that protects a human life. But for a frying pan or the frame of an ordinary car, that benefit is not enough to justify the high cost. Many people will think, expensive because it is rare. But the truth is the complete opposite. Not rare, just hard to extract. Titanium is not rare like gold. It is the ninth most common element in Earth's crust, more abundant than copper or lead. And yet, we never find pure blocks of titanium lying around in nature. Because titanium is always locked tightly with oxygen inside oxide minerals. Titanium has an intense love for oxygen. When they combine, they form titanium dioxide, an ultra-fine powder. Thanks to its excellent ability to create a white color, this is the ingredient inside the toothpaste tube, the sunscreen layer, or the white painted wall we mentioned from the beginning. And this is where the paradox appears. Titanium dioxide in powder form is cheap and common, but it absolutely cannot be used to make aircraft skins or rockets. To obtain a pure, extremely hard block of metallic titanium, humans must break the powerful chemical knot between titanium and oxygen. In other words, to turn the white powder in a toothpaste tube into aerospace material, factories must consume a massive amount of energy and use technical processes so complex they become almost extreme. The metallurgical nightmare. To make steel, humanity has an industrial superhighway. Ore enters a blast furnace. Molten steel flows out continuously at an extremely low cost. But with titanium, that road is blocked completely. If the ore is placed into an ordinary furnace, titanium will immediately absorb oxygen and nitrogen from the air. The metal becomes brittle and breaks apart. Factories must take a complicated detour called the Kroll process. First, the ore is treated with toxic chlorine gas at high temperature to turn it into a liquid. Then, that liquid reacts with molten magnesium inside a sealed steel vessel. The entire reaction must take place, submerged in inert argon gas at more than 800 degrees Celsius to isolate it from the air. The result is not a stream of molten metal. It is titanium sponge, a rough solid mass like pumice stone. People must crush it, wash it with acid, then melt it again in a vacuum furnace to cast it into ingots. This process happens slowly, batch by batch, and consumes enormous amounts of electricity and human labor. The challenger of every tool. Once a pure ingot is finally obtained, the real machining challenge begins. Titanium is a mechanical nightmare. Because it conducts heat poorly, when it is cut, friction heat does not escape through the metal chips. Instead, it accumulates right at the cutting edge, destroying expensive CNC drill bits at astonishing speed. When welding titanium, even a tiny amount of air leaking in can contaminate the weld. The joint becomes brittle, then cracks apart immediately. Welders must use argon gas to shield it continuously. Declassified CIA records on the supersonic SR-71 Blackbird show that they had to redevelop the entire system of cutting tools, lubricants, and windshields from the ground up just to handle titanium. Each aircraft of that era was basically built by meticulous handcrafting. Titanium forces human to pay the price in patience and absolute precision. The best material does not always win. In the practical world of engineering, a material wins not because it is the strongest, but because it balances every factor best. Mass-market materials need to be strong enough, cheap enough, easy to mass-produce, easy to machine, and easy to repair. So the next time you see a consumer product advertised as made from titanium, do not rush to assume that it is better. Stay clear-minded and ask 3 questions. Where exactly is the titanium located? Does that part truly need the properties of titanium? And are the benefits worth the price difference? A material is only good when it serves the right mission. Titanium deserves its place in the sky, in outer space, or deep under the sea. But for a frying pan or a bicycle frame, steel and aluminum are the smarter choices. The world is built from materials that are good enough to be produced millions of times with ease. The chemical safe. Titanium is not unfamiliar. It is right there inside your toothpaste tube or your sunscreen. But metallic titanium, the strength that pierces the stratosphere, is still a luxury because humans must pay for an enormous chain of technology to tame it. If titanium is already this strange, then in the next episode, let's look at a much cheaper material, the aluminum can. Did you know there was once a time when aluminum was even rarer and more expensive than pure gold? And if your sunscreen contains titanium dioxide, do not worry, it is not preparing to fly at Mach 3. Thank you for watching Everyday Things Explained. See you in the next video.